Good morning, children. Welcome back to your chemistry class. Today we shall start with a new chapter, that is states of matter, liquids and gases. So you already know that there are various things around us. These things, they are made up of matter which has mass and they occupy space. So the matter may exist in any form, like they can exist in the solid state, liquid state, or even in the gaseous state, right? So today let us understand the different arrangement of molecules and their properties of the solid, liquid and gases. So as I said, that the matter may exist in any form, that is solid, liquid and gases, and these forms, they are termed as the three physical states of matter, the states of matter, where we don't have to study about solid in this chapter, but we will be discussing about liquid and gases, right? So now existence of matter in a particular state, it always depends upon the conditions of say temperature and pressure. For example, water, it is liquid at atmospheric pressure and at temperature above 0 degrees Celsius and below 100 degrees Celsius, right? Then at 0 degrees Celsius and 1 atmosphere, water solidifies to ice form, and above 100 degrees Celsius and 1 atmosphere, water exists in the form of a vapor. Water can exist in all the three states, all the three forms. What are they? It can exist in a liquid state as water itself. In the solid state, it is ice, and in the gaseous state, it is vapor. Clear? So what do these depend upon? They basically are dependent upon the condition of the temperature and pressure, as I told you just now. Now, these what are the factors that are responsible for the existence of this solid, liquid and gases? There are two main factors. There are two main factors on which these depend upon, or what we can say are responsible for the existence of different states of matter. So first is called as intermolecular forces, and the next one is called as intramolecular forces. Now let us understand what is intermolecular forces. These forces, they are also called as attracting forces, right, and cohesive forces. These forces, they always keep the constituent particles together. They keep the कहते जरा आवाजें कम करें constituent particles together. Okay. Now what about intramolecular? They are the separating forces. They can be termed as separating forces, right, between the particles of the matter. So these forces, they arise due to say thermal energy and kinetic energy, and these forces, they help the particles to move apart. They keep the particles apart, right? So the attracting and the separating forces, they oppose each other, and the net effect of these two forces, it is responsible for the existence of these three states of matter, that is your solid, liquid and the gaseous state, right? Now let us understand certain characteristics of solid, liquid and gases. This you have already studied, so I'll go little fast and I'll just I'm not going to write over here, I'll just give you an explanation. So let us know what are the main characteristics of the solid state. So when the attractive forces, they are stronger than the separating forces, isn't it? Solid, we know that the molecules are very closely packed. So what did I say? Attracting forces will be more than the separating forces, or intermolecular forces will be more than the intramolecular forces where in the solid state. So again, when the attracting forces is stronger than the separating forces, then the matter will always exist in which form? In the solid state. Thus, in a solid substance, the constituent particles, they are very well arranged in a regular pattern. So, the solids, they always have definite shape, definite volume. Correct? Then, the interparticle separation is very small, and that the particles, they are incompressible. So, the particles, they are incompressible. So, because of the presence of these strong forces of attraction, the motion of the particles of the solid is restricted. They do not flow, and hence we do not see diffusion, right, in the solid state. I hope all the points are very clear about solid. Now we are going to talk about the liquid state. Now, what is the nature of the liquid state? Some of the liquids, the attracting and the separating forces, they are comparable, right? While in other liquids, the attractive force is slightly stronger than the separating force, right? So the liquids, they have fixed volume, but the shape is not definite. So the liquid, it always acquires the shape of the container in which they are kept. Okay, now let's talk about the gaseous state. So when the attracting forces, which one? This attracting forces, they are weaker than your intramolecular or the separating forces, then the matter will exist in which form? In the gaseous state, right? Or in the gas form. Thus the molecules of this gas, they can move almost independently of one another in a random manner. So when, for example, a gas is enclosed in a vessel, the molecules, they move to occupy the entire space that is available. Thus the gas, they can be compressed by applying pressure on them. Why so? Because the molecular separation is large, because the separating forces are larger than the attracting forces, and because of this weak force of attraction and also the large molecular separation, these gases, they also show diffusion. So these were some of the characteristics of your solid, liquid and the gases. Clear? Now always remember that the ionic forces, they are the strongest forces, followed by the covalent forces, and lastly the van der Waals forces. As you all know, they are the weak forces. So I'm writing it down over here, that your ionic forces, they are strongest. Then comes your covalent forces, and your van der Waals forces are the weakest. Okay, so you should always remember about these forces. So the idea of the strength of the intermolecular forces, it can always be determined how? From the boiling point of the substance. So higher the boiling point, greater will be the magnitude of the intermolecular force. That is, higher the boiling point, it will show ionic forces. Lowest the boiling point, it will show the van der Waals forces, and so on. So some of your intermolecular forces, right, they can be, so some of the intermolecular forces are, first one, it is dipole interaction. I shall be explaining all these forces today. Okay, so dipole interaction. The second intermolecular force is your dipole induced interactions. Then the third one is your ion dipole interactions. Then fourth kind of your intermolecular force is your ion induced interactions, okay, or in dipole induced dipole, ion induced dipole interactions. The fifth one is your dispersion forces, okay. This dispersion forces is also called as London forces. Then the sixth one is your hydrogen bonding. So today we are going to study about all these 6 types of your intermolecular forces, okay. So let us begin with some of the intermolecular forces. So the first one that we are going to talk about is your dipole interactions, okay. Now these forces of attraction, they occur among the polar molecules, okay. So this dipole will be your polar molecule and this will also be your polar molecule, correct. So these forces of attraction, they always occur among the polar molecules, which they have permanent dipoles, in which the positive pole of the molecule, it attracts the negative pole of the molecule, okay. So let's take for example, your one polar molecule could be say HCl and this is HCl. So this is electropositive, electronegative, electropositive, electronegative. So what did I say? The forces that you can see between the negative and the positive molecule to bring them together. What is this kind of force also called as? It is also called as Keyism forces, and these are the strongest forces. Why are they strongest forces? Because there is force of attraction on the opposite charges. So this is dipole-dipole interaction is your strongest force. I hope this is clear. So these attractive forces, they decrease with the increase in the distance. If the distance increases, then what will happen? These attractive forces are going to decrease between the dipoles. So the dipole-dipole interaction, they are stronger than any other forces that we are going to discuss. Now we come to the second one, that is your dipole-induced interactions, okay. So your dipole-induced interactions or dipole-induced dipole forces, they are also termed as Debye forces, okay. What are they also called as? Debye forces. So over here, dipole means this will be polar in nature, right? Induced means this will be a non-polar molecule. So this type of attractive forces, they operate between what? Between the polar molecules and the non-polar molecules, right? And they have no permanent dipole. They have no permanent dipole. So the mixture could be between an acetone and carbon tetrachloride, isn't it? And they experience attractive forces of which kind? Dipole-induced interaction. So these forces, they always depend upon the dipole of the permanent dipole and the polarizability of the neutral non-polar molecule, okay. So let's take an example. Polar could be your HCl with the positive and the negative. Now non-polar are what? Like your hydrogen, chlorine or carbon tetrachloride, as I said. Methane also you can take. So So you may take any of these. So I suppose I take hydrogen molecule. Okay. So what are we going to see over here? This is positive and this will become negative because all the electrons are going to move towards it. So we are going to see what kind of bonding between the polar and the non-polar dipole-induced interactions. Okay. They are also termed as what? Debye forces, and they are also strong forces, not stronger forces. They are called as strong forces, but not as stronger as the dipole-dipole interaction. Okay. Then we move to the third one. That was your ion dipole interactions. Okay. So let's understand what do we mean by ion dipole interaction. Ion could be your, either it could be your cation or it could be your anion. Okay. And dipole means it should be a polar molecule. Did you follow this? So the attraction between an ion, which could be a cation or an anion, and a polar molecule is going to show what kind of forces? Ion dipole interaction forces, right? For example, let's take when NaCl, it is dissolved in water, like NaCl dissolved in water, right? So the polar water molecules, they are attracted towards what? The sodium ion and the chloride ions, right? So the strength of this interaction, it depends upon the charge and also on the size of the ion and the magnitude of the dipole moment and even the size of the polar molecule, right? So for example, let's look at this, like this is sodium, okay, and this is surrounded by water molecule. So H and O, this is positively charged, we already know that. So what is this? This will attain a negative charge, this has a positive charge, this has a positive charge. So can you see the attraction between the two? Similarly, if you see over here, then it will get attracted by the oxygen. Then oxygen is here, hydrogen, they are all plus. Getting my point? Over here, this is minus, this is H plus and H plus. So what did we see over here? That there was an interaction between the ions and the polar molecule over here. Correct? So the strength of this interaction, it completely depends upon what? It depends upon the charge and even the size of the ion, right? And the magnitude of the dipole and the size of the polar molecule. Correct? We then next move to the fourth one. Fourth one was which one? Ion induced dipole interactions. Okay, so ion induced dipole interactions. So ion means it has to be either cation or an anion. Okay, and induced dipole means it should be a non-polar molecule, right? So over here, what do we understand? A non-polar molecule, it is going to be polarized by an ion present near it, and thus it is called as an induced dipole. Correct? The interaction between this ion and the induced dipole, it is called as ion induced dipole interaction. So let's take few examples over here, like in the presence of, suppose I have a nitrate NO3 minus, okay, an iodine molecule gets polarized. So what is your iodine molecule? It is your I minus and this nitrate, it gets polarized by the iodine molecule. So this ion, it is electronegative and iodine is electronegative. Is that clear? Another example you can take, like for example bromine which is minus, okay, and a non-polar molecule means hydrogen and hydrogen. Now this will be electropositive, all the electrons move this side, it becomes electronegative. So the bond that is formed between them, this is called as ion-induced dipole interaction. Okay, the strength of the such interaction, it depends upon the charge again of the ion and the ease with which the non-polar molecule it gets polarized with it. So this was your ion-induced dipole interaction. So the fifth one was your dispersion forces. Dispersion forces, as I told you, they are also called as London forces. Okay, so over here, even your non-polar substances, like for example your chlorine or methane or oxygen, they experience some intermolecular attraction because they can be condensed to liquids and then to the solids when they are further cooled to very low temperatures, right? In such liquids or solids, the interactions between these particles must exist to cause them to hold the molecules together. Is that very clear? So over here we are going to see instantaneous dipole-induced dipole. What did I say? It is instantaneous dipoles with the induced dipole. Okay, so instantaneous dipole means it will be non-polar molecule. Okay, and your induced dipole is also your non-polar molecule. So at any given moment, the electron density of the particle can be unsymmetrical with more negative charge on one side than the other, right? Is this clear? So for that particular instance, the particle is dipole and we then call it as instantaneous dipole. Again I repeat, what do I mean by this instantaneous dipole? For a particular instant, the particle is dipole and we call it as instantaneous dipole. So this particle with the instantaneous dipole, it causes the electron density in its neighboring atom and they become dipole between and they are called as induced dipole, right? And these two atoms of temporary dipoles, they now attract each other and it is called as London forces. It is also called as dispersion forces. They are also termed as dispersion forces. So for example, non-polar with another non-polar. So what did I say? Suppose I take hydrogen over here. So one side, for instance, one side is all negative charges, the other side is all positive charges. What about this induced dipole? We take another hydrogen atom. Over here it will be negative and here it will be positive. So what do we see over here? We see the dispersion forces or the instantaneous dipole-induced dipole forces or the London forces between the two, right? And they are the weakest forces. They are the weakest forces. The strength of this force, it completely depends on the polarizability of the electron cloud of a particle, right? Then the number of atoms that are present in a molecule, and it also depends upon the molecular shape of the molecule. I hope till here everything is clear. We come to the last kind of forces, that is hydrogen bonding. We come to the sixth force, that is the hydrogen bonding. So this hydrogen, it is bonded to highly electronegative atom through which kind of a bond? Through a covalent bond, right? So the electronegative atom, it tries to pull all the shared electrons towards itself, right, resulting in some partial positive and partial negative charge. As I had been showing you in the other forces, I had shown it to you like this. So what did I show you? There was a partial positive and a partial negative charge over this. So why does this happen? Because the electronegative atom, it tries to pull all the shared pairs of electron towards itself, resulting in what? One becomes electropositive in nature, the other becomes negatively charged. Now this positively charged hydrogen atom may attract the negatively charged atom of some other molecule, and the two molecules, they are linked by weak forces. And what are those weak forces of attraction called as? Hydrogen bonding, right? So this hydrogen bonding, it is always represented by a dotted line. So let's take for example hydrogen and fluorine, hydrogen fluoride. So this is electropositive, this will be electronegative, right? And they have this force of attraction. Now this is, again I write down H and F. So this is electropositive, this is electronegative, this is electropositive, this is electronegative. So now this electronegative, it tries to pull the shared pair of electrons towards itself, and thus what are we going to see? Here we are going to see some hydrogen bond that is formed. Okay. So what are these dotted lines called as? They are termed as hydrogen bonds. Clear? Now, one thing you should know, the bond length between fluorine and hydrogen. Okay, the bond length between fluorine and hydrogen, this is 255 picometer, right? And the bond length between hydrogen and fluorine, this is the hydrogen bond I am talking about. Now I am talking about the covalent bond between hydrogen and fluorine. This is 92 picometer. This is the bond length between hydrogen and fluorine, which is a covalent bond, and 255 picometer is for the hydrogen bond between hydrogen and fluorine and hydrogen. Okay, so this bond energy, write down the bond energy of hydrogen bond is always between 3.5 to 40 kilojoules per mole. Okay, of covalent bond is always 400 kilojoules per mole. Now what are the conditions for hydrogen bonding? First conditions for hydrogen bonding, you may note down. The first could be high electronegativity of the atom bonded to hydrogen, right? High electronegativity bonded to hydrogen atom, and this, if you remember, fluorine, chlorine, bromine, and then iodine. This is the series. Okay, then second one, small size of electronegative atom, it shows better hydrogen bonding. Okay, so large size means less attraction. Okay, that means less polarity also is formed, and therefore it will show less chances of hydrogen bonding. So you already know fluorine has the smallest size, so this is going to show the strongest hydrogen bonding over here. Is that clear? Strongest, I just said hydrogen bonding, but this hydrogen bond is the weak bond. It is not a very strong bond. Okay. So with this, all the forces that I have explained you today, understand them. Then we'll come back with the other part in the next video. Thank you.